Hi, Miss Co here. I am going to record a video lesson for Unit 2, Section A, okay? So the first thing that we want to remember from Unit 1 is that any triangle has something really interesting about it. If we were to add up the angles in a triangle, they would always equal 180 degrees, okay? So every single triangle has 3 angles, and when we add up the size of those angles, every single time it will equal 180 degrees, which is kind of cool. But it also helps us to be able to learn some things about angles if we don't know all triangles, if we don't know all of the angles. So let's take a look at the first picture that you have on your 2A notes, okay? And that picture looks a little bit like this, okay? So we have a triangle, and we know that this top angle is 45 degrees, okay? And this angle is 50 degrees, right? And I'm gonna make this a little straighter, guys, because this is a straight line. And we need to find this angle here, and also this angle, okay? Which is an exterior angle. You can see how that line extends straight right past this line here. Now, one of the things that we talked about when we were in Unit 1, not only did we learn that triangles, their 3 angles add to 180 degrees, but we also learned that angles on a line add up to 180 degrees also. And we're going to use those 2 pieces of information to solve problems like this. Okay, let's do this inside angle first, this one, okay? We know that we have 180 degrees for every triangle. So that's what we're gonna start with. And we know that we've already used 45 degrees on this angle at the top. We also used 50 degrees for our angle here. So if we were to subtract 45 and 50 from 180, okay, what are we going to be left with from our 180? So all you need to do is subtract these, okay? And when we do subtract those, we're left with 85 degrees, okay? 85 degrees. And that means that this angle right here has to be 85 degrees. Now, we still want to know our exterior angle there. And so what we're going to do is start at 180 degrees again. That's because our angles are on a line, and that means they have to add up to 180 degrees also. So in order to find this missing angle, we're just going to subtract from 180 again, and we'll get 95 degrees. So this missing angle on the outside is 95 degrees. So those are 2 pieces of information that are really important when you're working problems for 2A, part 1. Okay, just 2A in general, all right? So let's go ahead and look at another example, okay? If we were to have a triangle kind of next door to another triangle, like so, and we knew that the angle here was 40 degrees, and we knew that this angle was 40 degrees. How could we find the angle here and the angle here? Okay? And we do have two different triangles here, but you can see that our angles that we're looking for, again, they're on a straight line. So we're going to use what we know, which is that for every triangle, all their angles add to 180 degrees. And we know that we can subtract from 180 to find a missing angle. And we want to subtract both of the angles that we know. And when we do that, we're going to be left with 100 degrees. And that's what our angle here is going to be, 100 degrees. Okay? Now, how do we find this angle next door? Well, again, what we have is a situation where we have two angles on the same line. And we know that angles on a line also add to 180. So to find that missing angle, we just need to subtract from 180. And we know that it's 100 degrees next door, and so our missing angle, all right, when we do that on our calculators, that missing angle is going to be 80 degrees, okay? So remember, when you're looking for missing angles, okay, remember that the angles of a triangle always add to 180, and angles on a line also add to 180. So we can use that to find missing angles by subtracting the angles that we know from 180, okay? The next thing that's on our lesson has to do with isosceles triangles. What is that? Isosceles triangles. So I'm going to write that isosceles. Kind of a weird word. All it means is that it's a triangle and two of the sides are equal, okay? And we'll say that this angle that's between our matching sides, we're gonna make that red, okay? That's called our vertex angle, okay? And it's the one that's between our matching sides, right? When we have matching sides like this, what we know is that the angles that are opposite the matching sides are also matching. And when we're talking about matching, when we're talking about triangles, remember we use the word congruent. It means it's the same measure. That means the length of the two lines is congruent, and also the measure of the angles opposite those lines are also congruent. And remember, our symbol for congruent looks kind of like that, okay? And we can use the word equal as well as congruent. So congruent is a lot like equal for geometry, okay? And this is really helpful when we're looking for missing sides or missing angles. So remember, if you have two congruent sides, and our congruent sides, we always know they're congruent by these matching lines that are on the sides. And that means we always have two congruent angles as well. And for this triangle, it's this angle is opposite this first side. Opposite our second congruent side is this angle. But the angle that's our vertex angle, that's never going to be those congruent angles, okay? Let's do an example of a problem that you'll see like that. This is an an example from your notes. It's an isosceles triangle that you see there in your notes on page 2. And we know that because we can see that we have these symbols on our triangle, and those symbols mean that those two angles are congruent. And you can see how my triangle's a little funny, but so long as you see these symbols, that's how you know that those two angles are congruent or equal, okay? And we even have some information here. So we have 38 degrees, that's the measure of our angle B. Okay, and then angle A over here, instead of having a measure, we actually have an expression, right? 3x plus 2, right? We also have our marks that show us that the sides are congruent. So because we know that our angles are congruent, we can set our 3x plus 2 equal to our 38 degrees and solve for x. Our problem is asking us to solve for x. And of course, remember, to solve for x means x needs to be all by itself and positive. So let's see how we're going to work that algebra. We're going to set that expression equal to 38 degrees or 38. And when we're trying to get x by itself, we want to look at what's being done. Here's add 2, so we'll do the opposite to both sides. So we'll subtract 2 from both sides. Now, if it helps to keep your sides clear, you can write a little line that's called a gate, and it just helps you to remember that you have two sides in every equation, and you always have to do the same thing to both sides so it stays equal. When we subtract 2 from both sides, we're going to get 3x equals 36. 38 minus 2, okay? And now we need to know, well, I've got a 3 here, so x is not all the way by itself yet, is it? So what we want to do is we want to say, well, what's happening here? Well, this is multiply, right? And so we want to do the opposite. And the opposite of multiply is divide. So we'll divide both sides by 3. And when we do that, our 3 divided by 3 is 1, and we'll get x equals 36 divided by 3, or 12. Okay? So we were asked to solve for x, and our x is 12. Now, that doesn't mean this angle is 12, does it? Our angle is 38 degrees because we know these two angles match, okay? But our x value is 12, and we can check that. So whenever you see an x in an expression, it's a little placeholder. So we could also notice that instead of x, we could just write a little parentheses. It's a placeholder. So 3 is multiplying something, and then we need to add 2. And now we know that x is 12, so we can write 12 in that same spot where x was. And we can go 3 times 12 is 36, plus 2 is 38, right? And so when we plug x in, what do we get? We get 38. And that's correct because look, the other angle is 38 as well. So we know we got the right x. All right? Let's do another example. So the next example on our notes, we have a triangle that's, again, another isosceles triangle. That means we have two sides that match, two angles that match or are congruent, okay? These symbols mean that those two angles are congruent. These symbols mean those two lines are the same exact length, or they're congruent. And we know that the measure of each line, or the length of each line, is being represented by an expression. And remember, an expression is a way that we write algebra with a variable. And when we find out what that variable is, it'll give us more information. So this is what an expression looks like. This side says it's 2y plus 15. We call that an expression. It's an algebraic expression. And an expression is different than an equation because it's not equal to anything when it's an expression, right? The other side is represented by 4y plus 5. But because we know these two lines are the same length, we can use these expressions to make an equation. So let's do that. Since the lines are the same length, we're going to take the expressions for the lengths of those lines and set them equal. So we have 2y plus 15 equals 4y plus 5. We used our expressions to make an equation, right? They're equal. And because we have an equation, now we can actually find out the value for y by solving our equation for y. And to do that, we've got to get y all by itself on one side and the rest of the numbers on the other side. So let's go ahead and do that. We know that this is add 15, so we'll do the opposite to both sides. And remember, you can only subtract 15 from the numbers part, okay? And so when we do that, when we're working our equations, it sometimes helps students to have a gate so you can remember which side, that you've got two sides and you're doing it to both sides, okay? And when we subtract 15 from both sides, I want you to see that you're not subtracting 15 from our y terms. You can't do that. They're not like terms, right? So we'll subtract 15 here and it'll get us 0, right? We don't need to write that 0, so we just cross them out. We call it canceling. But it leaves us with this 2y equals 4y. And now we have 5 minus 15, so that'll leave us with 4y minus 10. On the calculator, you can put in 5 minus 15 and you'll see it'll give you a negative 10. So that's how we'll do that. Now we want to get both y's on the same side. So I'm going to notice that there's an invisible add in front of the first terms in our expressions. We don't see it. We're only seeing that a subtract. If it's a subtract, we'll see a negative out front. So since we know this is possible or positive, we can subtract, which is the opposite of our positive, 4y from both sides. And when we do that, we're going to get negative 2 minus 4 is negative 2. Negative 2y equals negative 10. Okay? So I'm going to come up over here to finish us off. So negative 2y equals negative 10. Now I said to solve, we need to get y all by itself and positive. We still have something right by our y. It's a negative 2. And that term in front of our variable, you see how it's touching our variable? That means multiply. So now what we're going to do is we're going to divide both sides by negative 2. And when we do that, we'll get y equals, and when we put it in our calculator, negative 10 divided by negative 2 is going to give us a positive 5, and that is the value for y. We can use that now to find the length of our side. So we talked about how y is a placeholder. So now what we can do is where y is in our term, we can now substitute 5, okay? And we can see that 2 times 5 plus 15 is 25. Let's see if that ends up being the same on our other side. So again, we're going to substitute 5, the same place we've got our y. And then we're gonna solve our expression. So here's where our 5 will go, right? So 4 times 5 is 20, plus 5 is 25. So now we know both sides are 25 long, and that means we got the correct y. All right, we're gonna do one more example in 2A part 1 using what we know about isosceles triangles. Now remember, isosceles triangles have 2 congruent sides, that's equal, and we also know whenever we have a triangle with 2 congruent sides, we also have 2 congruent angles. So I'm going to show you this last example. You might have remembered this triangle from class. We did examples like this on the board. And this triangle has A, D, C on those. Got a B here. This angle is called Q. This one is U, S, and R. And what we're told is that, look, we've got marks that are congruent there and here. And even though my triangle, I drew it, they're not really the same length. If you see these marks, it means that even if the picture isn't just right, you know that those sides are supposed to be congruent or equal, remember? So congruent. We are also told that our angle here is 32 degrees, okay? Well, the first thing that I want you guys to notice is I've got congruent marks here on both of the sides. And of course, the angle in between our matching sides or our congruent sides is our vertex angle. That's never the matching angle. That means this angle has to match angle Q, okay? And for these sides that are matching, that means S and T also have to be congruent. When you see an image like this, remember to mark the angles that are congruent, right? So if this angle is 32, that means Q also has to be 32, right? We're asked to find all of the angles. We know that this triangle has to add to 180. So if we subtract 32 for our angle Q and then another 32 for our angle here, okay, what are we going to find out is left? Well, it's going to be 116 is going to be left when we subtract 32 and another 32. We've got to subtract both angles from our 180 degrees. And that means that our angle R is 116 degrees. Now, we also need to find angle S, right? And what we know is that angle R is on the same line as angle S. So to find angle S, we need to subtract 116. Actually, I'm going to put that in red so that you can see that it's that angle R next door. So it's we're subtracting 116, or the measure of angle R. And when we do that, we're gonna find out that we have 64 left for S, because these two have to add up to 180. So we know angle S is going to be 64 degrees, and we got that by subtracting its neighbor from 180, okay? And since angle S is 64, we know that angle T is also 64, right? Because these two angles are congruent, okay? Now, in order to find our last angle, angle U, we're just gonna subtract 64 from 180, and then the other 64. We're gonna subtract the two angles that we know because those two angles were matching, right? And so when we subtract from 180, this is going to be 128 from 180. It's going to leave us with 52 degrees for angle U. 52 degrees for angle U. Okay? This is important. You're going to need to practice your problems like that. You're going to see a problem like that on your test for sure. All right? All right, well, thank you so much. That is our lesson for 2A part 1. Thank you.